Once again, Rich Tansky with ChemMasters. We're here this morning for the 10:30 webinar. Again, I apologize for the problems that we've experienced this morning, and I know a lot of you probably logged on an hour ago. But again, I apologize, and we're now ready to get running. So, John will be talking to us this morning about curing and protecting in the age of Type 1L cement. I know it's a very popular topic as we are out and about talking with customers and contractors. People are still trying to figure out which end is up when it comes to 1L cement and how we cure and how we protect it long term is really important. So John's going to walk us through that this morning. And a little background on John real quick. John joined ChemMasters back in 2009 and is currently Vice President of Marketing and Business Development. His role includes representing ChemMasters at various industry trade associations, including American Society of Concrete Contractors, the American Concrete Institute, where he serves on various technical committees associated with curing, repairing, and protecting concrete. Recently, John accepted an appointment to the ACI Technical Activities Committee that oversees the 400 or so technical committees and subcommittees. So without further ado, I'll give you John.
Thank you for that introduction, Rich. And I want to reiterate my personal apology for the issue with the start time. I believe that was entirely my fault. So thank you very much for your patience and for joining us this morning. So the webinar, as Rich mentioned, is entitled One Step Ahead, Curing and Protecting Concrete in the Age of Type 1L Cement. I'm excited to speak with you this morning and hope you'll find it informative, interesting, and a valuable use of your time. And as the title implies, concrete produced with Type 1L cement requires that we address critical issues like curing and protection differently than concrete produced with Type 1-2 ordinary Portland cement. Over the years, Type 1-2 has blessed us with a very forgiving product for placement and finishing. And as a result, it's possible that we become complacent with taking advantage of that forgiveness. There we go. Our webinar today will focus on the realities of working with concrete produced with Type 1L cement and the best practices associated with optimizing outcomes for placement, finishing, and durability. In many respects, it will be a reminder of those best practices that have always existed, even with Type 1-2, but we've been able to get away with doing less. In the age of Type 1L cement, those best practices are no longer a recommendation, they're a necessity. And here's the bottom line. Type 1L cement has eliminated the safety factor associated that we become very familiar with and relied upon with Type 1-2. There's no wiggle room, no cutting corners, even corners we become accustomed to cutting. I like to use the analogy of the children's game of Don't Spill the Beans, where beans are added to the pot until the tipping point is reached and the pot turns over. And that lost safety factor with Type 1L cement means that the tipping point for concrete is far easier to surpass than we become accustomed to with Type 1-2, particularly when we fail to strictly adhere to best practices for placement, finishing, and curing. Let's be clear, there is a cost associated with strict adherence to best practices, but I promise you the cost of best practices is far less costly than the cost of failures. We don't want to turn Type 1L cement concrete into a high-stakes game of don't spill the beans. Here's another truth. Concrete produced with Type 1L cement means you're already starting with a full pot of beans before the concrete even arrives on the job site. That's what it means to lose that traditional safety factor associated with Type 1-2. Here are some of the ways in which the beans have already been added to your pot. As anybody who's familiar with use of Type 1L cement can attest to, there is an issue with bleed water, and there is little to no bleed, and it's difficult to know what about the timing as to when finishing can occur. It's very easy to finish bleed water into Type 1L cement prematurely, and which has a host of problems associated with it. We're all familiar with the surface drying and crusting. Type 1L cement dries very rapidly at the surface. It's often described as water starved, and that drying and crusting can increase and does increase the incidence of cracking, surface defects, weaknesses, scaling, and a host of other problems. The water demand and water sensitivity with Type 1L cement is extremely increased. So small changes that we might be familiar with in Type 1-2 have huge impacts on the outcome of strength and durability with Type 1L. As you may also have become aware of, Type 1L cement has difficulty achieving the same early strengths and set times associated with traditional Type 1-2. That means you have less scheduling flexibility, and you may not achieve the early break requirements that might be in a specification for your projects. And there is an increased cement variability. Generally, Type 1-2 cement is very consistent amongst various suppliers, both within a region and outside of a region. But with Type 1L cement, there is greater variability between suppliers and even between plants that might have different sources of raw materials that might be from the same supplier. And there's a learning curve associated with each supplier in each plant. You can't assume that what your experiences at one plant and in one region are going to be similar across all of them. So if you're already starting with a full pot of beans that are beyond your control because of the use of Type 1L cement, it only makes sense that you can't afford to add any more beans that are within your control. So think of best practices as bean avoidance. Read this slide carefully. Best practices did not change or begin with Type 1L cement. They are not unique to Type 1L cement. They've always existed. It's the safety factor that's changed in the age of Type 1L cement. The safety margin no longer exists. The safety factor is gone. So we need to rely more strictly on our best practices going forward. Here are some critically important best practices when working with Type 1L concrete. Collaborate early with your ready mix supplier. You've got to work hand in hand with each other in order to get optimal outcomes. You've got to conduct lab and field test batches. You have to evaluate set times and finishing windows, bleed characteristics, the workability and timing. You have to confirm the admixture compatibility and dosage ranges. And this needs to occur with each plant and each supplier, not just with one. Need to perform test pours. Place trial slabs under realistic job site conditions, and validate that your finishing sequence and timing, your crew size and equipment needs, your surface response, whether you're going to experience crusting, tearing, stickiness, and at what point, and adjust your finishing plan accordingly. You need to do this ahead of time. Build mock-ups, particularly when appearance is vitally important. Decorative concrete, polished floors, architectural surfaces. Establish acceptable finish standards with the owner and GC. If everybody's not on the same page as to what those expectations are, you're bound to run into some problems. And then document those expectations so that not only does everybody understand them, but everybody remembers that they understood them at a later date. Of course, it's always recommended to have a pre-pour meeting. It's more critical with the use of Type 1L cement. That needs to take place with all of the stakeholders involved in a project. You need to review the mix design and expected behavior, the roles and responsibilities of each of the folks that are on the job site, the environmental mitigation plan according to what the temperature and weather might be like expected from day to day, the finishing and curing sequence and timing, and make sure that everybody understands that there is a tighter margin for error. So everybody understands that these processes need to take place in a proper sequence and timing. And then set the expectations. There is no safety factor. Reinforce to your crews and your stakeholders that timing is important and much more important than it used to be. The conditions in which the placement and finishing take place are much more important, and the execution must be precise. So it's also critically important to plan ahead. If you show up on the job and it's a hot, windy day or it's a cold, low humidity day, that's the wrong time to begin thinking about a hot weather or cold weather concreting plan. You better have prepared well ahead of time so it can be implemented immediately as needed. Same thing goes with a finishing plan. Define what the timing triggers are. Not wait and see is not appropriate because you're going to have little to no bleed water. So you need to be aware of when are we going to get on this to do some finishing. You have an idea of what the finishing sequence is going to be and the timing involved with each of those steps. Plan for longer and less predictable set times, and ensure that the proper crew size and experience level is on the job site. More than having a plan, you also need to be prepared with materials and equipment that's needed to execute that plan. They need to be on the job site ahead of time, not in the distributor's warehouse. So you need to stage material. To the best of your ability, look ahead, understand what the weather conditions are going to be like, but you have to have these materials ready to go even if there's an unexpected change in the weather. You have to have materials and equipment associated with evaporation retarders. ChemMaster's spray film is a great evaporation retarder that we'll talk about shortly. Fogging equipment, if that's your choice for a evaporation retarding process. Finishing aids such as FA1 Nano First Aid for concrete, and you need to make sure that your crew is trained on how to use and when to use each of these products. Confirm your curing strategy in advance. Timing with Type 1L concrete is critical. Be ready to implement your curing plan immediately. And as you will see going forward, doing the minimum might have been acceptable for Type 1-2 concrete, but it's not enough to produce reliably acceptable outcomes with Type 1L concrete. Verify your application rates, the timing, your equipment readiness, and expect to do more. Don't rely upon the minimum. Planning ahead also means, to the best of your ability, align your schedules to the expected conditions. I know schedules are a sensitive topic. Everyone wants the job done as quickly as possible. but you have to ask yourself, is it worth risking the entire project to save a few days? What's the return on investment for that? It's important that all the stakeholders on a project, including the owners, understand and accept this as a critical element. So here are some of the best practices associated with placing, finishing, and curing concrete produced with Type 1L cement. So in terms of placing, the challenges are slow to no bleed, a higher water demand, and rapid surface drying. So the best practices associated with that are to place as near to the final position as possible, strike off quickly, proper vibration, monitor the weather, and liberal use of initial curing, such as an evaporation retarder. Avoid adding water. I know that blessing the concrete or adding water at the truck has become such a common part and parcel with Type 1-2 ordinary Portland cement because it's very forgiving. But you're already at the maximum water demand by and large when that truck leaves the plant, the ready mix plant. Adding extra water is only asking for trouble. It's going to increase the water to cement ratio, decrease the strength and durability, and set yourself up for problems for scaling and others. Avoid overhandling and avoid delays. You gotta get through the placing quickly and efficiently. For finishing, the challenges also include little to no bleed water. Now you run into the potential for surface crusting, particularly if you're not using an appropriate initial curing method. And you've got a very tight timing window. So finish on a set, not on the bleed. Initial and intermediate curing, use an evaporation retarder, fogging equipment. By the way, intermediate curing is simply the extension of initial curing and evaporation retardant as needed. Minimize the number of passes you're doing. Use finishing aids to help improve that surface quality, reduce defects, and also it helps speed the process so that you can get onto final curing as soon as possible. Watch your concrete, understand your concrete. Avoid waiting for the bleed water that may never come. Avoid adding water for finishing, and avoid over troweling. We need to get moving on this product, this material, this Type 1L cement, in order to get it finished as quickly and effectively as possible. And then we get to curing. The surface is prone to rapid moisture loss and drying and crusting. So we need to prevent that moisture from exiting that surface in order for it to develop its full design strength and durability. It's critical to hydration at the surface. Hydration is the chemical process by which cement and water react to form good, strong, durable concrete. The best practices are to start final curing immediately, as quickly as possible after final finishing. Use a curing compound that meets ASTM C309 or ASTM C1315. Consider doing more than the minimum. The minimum might have been fine for Type 1-2 ordinary Portland cement, but the minimum is not enough when it comes to Type 1L. Apply your curing compound uniformly and cure for the full 28 days. Don't cut it short. Avoid delayed curing. Incomplete coverage. A curing compound is only as effective as the coverage is. So make sure you're achieving the full coverage rate and don't leave any voids or holidays in it. And avoid early termination. Final curing is intended to take place for full 28 days. Give it its full 28 days. ChemMasters offers a powerful portfolio of one-step products to assist you throughout the placement, finishing, and curing process, including long-term protection. So at each step of the process, initial curing, finishing aids, final curing, long-term protection, ChemMasters has a product or a series of products that will help you achieve the best outcomes. This is the ACI definition of initial curing, a deliberate action taken between placement and final finishing of concrete to reduce the loss of water from the surface of the concrete. There's a lot of moisture loss that can take place with Type 1L cement between placement and finishing. We need that water, especially at the surface that is prone to rapid drying and crusting. So an essential best practice includes absolutely the necessity for initial curing. Initial curing is probably the best practice that has been most often overlooked with traditional type 1-2 concrete. And a case can be made that it is the most essential best practice with type 1L concrete due to the rapid moisture loss at the surface during placement and prior to finishing. This is one of the major factors contributing to crusting that is a common issue associated with type 1L concrete, where the surface crusts while the underlying concrete has yet to set. The slow bleed or lack of bleed water inherent to type 1L means that surface moisture is not being replenished from within, and premature drying or crusting is almost inevitable. Once the surface is dried or crusted, hydration stops. That chemical process stops by virtue that makes good, strong, durable concrete. And it's going to result in a surface that will never develop its full design strength or durability. One of the failures attributed to type 1L concrete are attributable to the lack of or insufficient initial curing. Here's the ACI definition for initial curing. Again, along with the most common initial curing methods. Evaporation retardant is probably more common than fogging, but both of them achieve the same, done properly, both of them achieve the same purpose. It's to prevent the rapid moisture loss and reduce plastic shrinkage cracking at the surface. Neither of them is or at least used in this manner, not a curing method, and they need to be followed by final curing. An evaporation retardant, this is the ACI definition, also called an evaporation reducer. A material applied to the surface of concrete before initial setting to reduce the evaporation rate of water without interfering with finishing operations. That's an important element. ChemMasters offers our spray film. It's a highly effective evaporation retardant to prevent the rapid moisture loss at the surface during placement and prior to final finishing. It's important to note that an evaporation retardant is not a finishing aid. These are not meant to be worked into the surface until the water portion of the formula has evaporated. So they are applied, they are about 95% water, about 5% is an active ingredient that forms a monomolecular film, and they are intended to allow that water portion to evaporate, leaving the film. The film then can be finished into the surface as needed. There are conditions, environmental conditions, in which use of an evaporation retardant isn't a one-time process. You may need to do it on, several different times, depending on the conditions and the timing of your final finish. Some additional best practices that you also need to plan ahead for. You need pre-planning and staging of equipment and materials. By the time you need them, it's too late to plan and stage, but use of windbreaks and sunshades, can be vitally important depending on the environmental conditions. And you need to be aware of the impact of conditions on your timing and placement. So a lot of coordination. You need to also perhaps alter your schedule to make best use of the conditions that are forecast. Use of finishing aids has also become an essential best practice for Type 1L cement. I like to think of these products historically as having been a solution in search of a problem. And the problem was created with the advent of Type 1L cement. So finishing aids improve the finishability, giving you a smoother, higher quality surface with fewer defects, but they also extend the working time of that surface, which is critically important, especially in hot, windy, and low humidity conditions, to prevent that crusting that is occurring. They also strengthen and densify the surface to improve long-term durability. So they make up for some of the performance issues that are associated with Type 1L cement. And they haven't become, they used to be kind of an interesting and valuable help. Now they're a necessity. ChemMaster's FA1 Nano First Aid for Concrete is a highly effective finishing aid formulated with reactive nanosilica. Prior to the introduction of Type 1L concrete, as I was saying, finishing aids were a convenience when finishing Type 1-2 concrete, but they really found their traction and adoption within the industry to overcome many of the challenges associated with Type 1L concrete. So FA1 Nano First Aid for Concrete will help minimize map and shrinkage cracking, deliver a smoother, higher quality surface with fewer defects. They enhance the finishability of concrete, allowing the tools to glide more smoothly without sticking. They reduce crusting while extending working time, and they harden and densify the surface to improve strength and long-term durability. Finishing aids make up for a lot of ills that are associated with Type 1L concrete. And then, of course, there's final curing. This is the ACI definition of final curing, and more specifically, external or surface curing. It has always been an essential best practice and is mandated by ACI 308 curing specifications. Final curing is a deliberate action taken between the final finishing and termination of curing to reduce the loss of water from the surface of the concrete and control the temperature of the concrete. So again, we're trying to keep moisture in the concrete in order for full hydration to occur at the surface within the cure affected zone, and to make sure that that surface achieves its full design strength and durability. It has always been an essential best practice, but it is ever more so in the age of Type 1L cement. I'm not sure an essential best practice can be said to have become more essential, but final curing certainly has. Type 1L concrete is already water starved at the surface, and it can't afford to lose any more water that might impede or stop hydration within the critical cure affected zone. It's that top 1/4 inch to 3/4 of an inch. Failure to fully hydrate cement within the cure affected zone results in a loss of strength and durability and will result in increased surface defects, cracking, and scaling. Again, doing the minimum for final curing might have been acceptable with Type 1-2 concrete, but it's not enough to produce reliable outcomes for Type 1L concrete. We'll see how ChemMaster's one-step products get you one step ahead here shortly. But again, we're worried about the cure affected zone, the top 1/4 to 3/4 of an inch, and retention of moisture for full hydration of the cement within that surface area. This is probably a good time to note the differences between internal cure and external cure or surface curing. External or surface curing is focused on the moisture loss within that cure affected zone. It's never going to be acceptable to tell an owner that 5.5 inches of your 6-inch slab is great and only the top half inch is a problem. The surface is what everyone sees. It's what everyone walks on and drives on. The surface is everything. So if you are at all concerned about the surface of your concrete, and we all should be, then external curing is mandatory. Internal curing is optional, and ACI backs that up. We have a nice piece on our website that goes into greater detail about the differences between internal curing and external curing, and I would invite you to go read that as well. There are a wide variety of effective final curing methods when meeting ACI 308 curing specifications. Each has its advantages and disadvantages, and they may be selected based on the specific project needs and limitations. Curing compounds are often considered the most versatile, and for the purpose of this webinar, we will focus on the ChemMasters one-step family of products. But amongst the various final curing methods, we have, of course, curing compounds. We have water cure, curing blankets, wet burlap, and plastic sheeting. And as you can see, each of them has their advantages and limitations or disadvantages, and can be selected based on the needs of a particular project. And here's how to get one step ahead with Type 1L concrete. With the addition of reactive penetrating silane to provide long-term protection from damage caused by the ingress of water and chloride, freeze-thaw cycles, and the use of de-icing chemicals. We like to say, don't just cure it, protect it, which in the age of Type 1L concrete is particularly important. The ChemMasters one-step products, they all meet ASTM curing specifications. They have include a integral penetrating silane that penetrates deeply into the concrete, where it reacts within the capillaries and pores to form a silicone that repels water and chlorides and provides long-term protection, far more than just surface protection. Don't stop at curing your concrete, especially your Type 1L concrete. We understand that it is more prone to damage and loss of surface strength, so we need to do all that we can to prevent any cracking and scaling that might occur, in particular over that first critical winter, but throughout its lifespan. Our one-step solutions, here's a comparison of the typical process needed to cure freshly placed concrete and then apply a reactive penetrating sealer. Typically, you would have to, and traditionally, cure the concrete via one of the methods that we showed earlier. And one of those could include the use of a film-forming curing compound. Then we would remove that curing compound. We would have to then prepare the surface for application of the sealer. We would need to apply the penetrating sealer, and we need to allow that to cure. So this is a multi-step process that takes, certainly more than a month. And if we're all concerned about schedules, this is probably an unnecessary process, because you could do it in one step with the ChemMasters one-step products and be done. So this is how our one-step products work. They are let's call them a hybrid products. They consist of a film former that resides on the substrate surface. They cure concrete to ASTM C309 or ASTM C1315 specifications. But then they also include a deeply penetrating reactive silane. And they react within the capillaries and pores of concrete to form a silicone lining and a hydrophobic barrier. They reduce the ingress of water and chlorides, and they provide long-term protection against damage caused by freeze-thaw cycles and de-icing chemicals. Do more than cure. So here's how it works. As the material is applied to the surface, the acrylic membrane obviously provides a barrier to the evaporation of water. And the silane is drawn to the high alkalinity of the concrete. And so those silane molecules are drawn into and penetrate and coat those capillary pore walls and react to form a silicone lining. So we provide both the function of curing concrete, high performance cure, with a high performance silane protection. Let's compare moisture loss as ChemMaster's products go a step beyond traditional cures and well beyond the minimum curing requirements of ASTM C309. So ASTM C309 allows up to 0.55 kilograms per square meter of moisture loss, which is it's a significant number. Our typical ChemMaster's one-step products are up at about 0.3, which is about a 33% reduction in moisture loss at the surface. And remember, let's remember that less moisture loss means better hydration of the cement at the concrete surface. That means a stronger surface, fewer defects, reduced cracking, and better durability. But ChemMaster's one-step products go beyond that and are also fortified with a reactive penetrating silane. And that vastly improves long-term protection compared to traditional cures meeting ASTM C309. So we can see that, and we just looked at the fact that their greater moisture retention means better curing. So we provide that better early protection. Our one-step products vastly improve the performance in preventing the ingress of water and chlorides, better freeze-thaw durability. They're both user-friendly. I mean, applying a one-step product is no better or worse than applying a curing compound, even though it performs a lot more. And then the long-term durability and long-term protection is significantly enhanced with the addition of the penetrating reactive silane. So one insight is ASTM C642. It's a good measurement of the absorptivity of cured concrete. Increased absorptivity means greater ingress of water and chlorides, which means a decrease in durability. And ChemMaster's products can be tested to prove that they perform better than your traditional cures when it comes to ASTM C642 in reducing the amount of water absorption into the concrete cured with one of our one-step products. So ChemMasters offers a wide portfolio of one-step products to keep you a step ahead of the challenges associated with Type 1L concrete. ChemMasters one-step products are formulated with the performance needed for all your concrete projects. Our entire family of one-step products feature the same high-performance film-forming cures combined with reactive penetrating silane to provide long-term protection, and again, all in one step. Our options include water-based materials. We have materials that are made for their versatility for DOT applications. We have high-performance DOT and commercial materials, and we have products that were developed for their decorative and aesthetic qualities that can be used on decorative concrete. So we've got answers for each of the different project and application types that you may have. We're going to look at them a little more closely here. So Silencure SRT is ChemMaster's most versatile one-step product. It can be used on broom finish concrete, hand troweled and power troweled concrete. It can be used as a cure and protect. It can be used on fresh concrete. It has been used widely and successfully on cured concrete. It's water-based with an acrylic copolymer and the penetrating silane modified siloxane. Meets and exceeds ASTM C309 curing specifications. It performs quite well in terms of NCHRP 244, Series 2 and Series 4 testing that is commonly associated with state DOT requirements. It's non-yellowing, non-bubbling. It's kind of our use it everywhere product and performs exceptionally well as both a curing compound and as a deep penetrating reactive silane. Silencure DOT was developed specifically to address the unique needs of departments of transportation and appears on a long list of state DOT qualified product lists. Silencure DOT is uniquely valued, not just for its performance, but also for improving job site safety on DOT projects, where it can reduce the exposure of contractors to the dangers inherent to lane restrictions. One step instead of 3 steps means a 2/3 reduction in exposures. And lane restrictions are recognized as being extremely dangerous conditions for contractors to be working in. They're associated with a lot of accidents and a lot of accidents involving contractors. So anytime you can reduce the number of exposures, you are improving safety. Similar to most DOT products, Silencure DOT is a white pigmented wax emulsion, but it includes our penetrating silane sealer. So it meets ASTM C309 curing specifications and exceeds them. It is DOT approved in many states, and it exceeds most state requirements also for NCHRP 244, Series 2 and Series 4, which is used to evaluate penetrating reactive materials. Our DOT and commercial high-performance products are Silencure and the low VOC version Silencure A. They meet the demanding needs of DOT and commercial applications when used on broom finish concrete. These are products that are designed exclusively for use on freshly placed broom finish concrete. Both of them exceed the ASTM C309 curing specifications. Both of them meet and exceed most state requirements for NCHRP 244, Series 2 and Series 4. Both of them include a penetrating silane for maximum protection against water and chloride ingress, protection against de-icing chemicals and freeze-thaw damage. And we have both a high VOC and a low VOC option available. And we also have products available for decorative. We don't want to leave that out. ChemMasters offers a decorative solution that is our Certivex Guard Clear and our low VOC option, the Certivex Guard Clear AIM. They provide the same exceptional curing and long-term protection while enhancing aesthetics on a wide variety of decorative concrete finishes. This is difficult to achieve. Typically, the introduction of a silane water repellent into a high gloss material will significantly reduce the gloss. But the ChemMasters lab has formulated a product where we can do so and maintain those same high quality, high gloss aesthetics associated with any other high quality decorative material. So we have Certivex Guard Clear and Certivex Guard Clear AIM. Both are 25% solids acrylic copolymers with the penetrating silane shield for long-term protection. Both are non-yellowing. It's an advanced formula that provides long-term clarity of the film. They deepen and enrich the natural color of concrete with a high gloss finish, and they meet ASTM C 1315 Type 1 Class A and B specifications. And they look great. They perform exceptionally well. And the most important function when it comes to decorative concrete, beyond protection, is certainly aesthetics. People are paying extra for decorative concrete. They want it to look good. And ChemMasters Guard Clear and Guard Clear AIM can be part of that project. So in conclusion, we all understand that Type 1L concrete has its challenges, and the baggage or beans associated with Type 1L concrete are not going away. But it's not fair to say that all the poor outcomes that may occur are attributable solely to Type 1L concrete. We can improve those outcomes by recognizing that Type 1L concrete is inherently more sensitive to even minor deviations from best practices. And we can further improve those outcomes by getting a step ahead, using a ChemMasters one-step product with high performance cure and reactive penetrating silane. So not everything is the fault of Type 1L. It is certainly a more difficult product to work with, but if we maintain our best practices and go a step beyond with the help of a ChemMasters one-step product, we can improve those outcomes and get more reliable, satisfactory outcomes for long-term strength, durability, and appearance. So that is the extent of my presentation for today. I think I kept it within 48 minutes, which was not too bad. And I would certainly open the conversation up to some questions.
Hey, John, I just want to let you know we're at 48 minutes and 23 seconds. So good job.
Yeah.
So yeah, there are a few questions and comments that have come in, and so I'm going to throw those out for conversation. So with Type 1L, you mentioned something about lower strength with that material. So are we using our ready-mix producers needing to use more cement than they would with standard Portland Type 1?
Well, actually, it's a great question. Type 1L is slower to develop its early age strength, and I apologize. The nature of webinars is that there's a lot to cover, and maybe don't get as in depth as you would like to on each topic covered. So Type 1L cement is associated with slower early age strength. By 28, 56 days, it typically catches up with Type 1-2. The problem is if you've got a project where you've got 1 day, 3 day, 7 day break strength requirements that are specified by an engineer, you may have some difficulty achieving those. Only because Type 1L achieves those early age strengths more slowly.
So it just retards the strength development. How much has it been identified as far as how much carbon reduction is actually occurring by going to type 1L?
I haven't seen anything specific other than to identify that the overall problem is that there is about 8% of the world's carbon emissions are associated with the production of cement, clinker. I have not seen any specific attribution of what kind of savings, carbon emission savings, are associated with Type 1L cement. That isn't to say that that statistic isn't out there. I just don't recall seeing it.
I gotcha. Um, with type 1L, are you aware or is the industry seeing any more slab curling?
Well, anytime you have differential evaporation, differential curing, you're going to have an increase in curling. So if that surface is drying prematurely, then you can well imagine that it would enhance curling. So I think a contractor would probably be better. Again, I don't have anything other than comments that I've heard. I don't know that there's statistics available, but it would certainly, I would expect that the incidence of curling with type 1L would be increased. And it's further, that reinforces the need to maintain as much moisture in that surface as possible. So initial curing and final curing are so exceptionally important.
I know there are some questions that are just a challenge to really answer, simply because I don't know if enough testing has occurred with type 1L at this point. But do you have any insight as to slab moisture and moisture testing, to prepare for flooring? The 2170 test or the 1869 test, the calcium chloride test or the floor meter test?
Again, I have not seen statistics. I'm not an expert in the use of those tests, but I could surmise that test results might be less reliable given the fact that the surface prematurely dries, and that does not mean that you have seen a moisture reduction deeper into the concrete. And so, to the extent that those tests are measuring near surface moisture versus moisture throughout the slab, there might be some inconsistency.
A few more questions are coming in. Um, when is it appropriate to apply Silent Cure to a broom finish concrete surface?
So the with type 1L concrete, it's vitally important that a final curing method go on as as quickly as possible after final finish. So, certainly no more than an hour or two. I know that there are sometimes limitations as to, the size of a slab and the equipment that would be necessary to span a slab and apply cure. I'm also aware of contractors who have created equipment that might be telescoping and extensions in order to do so without having to step on the slab and wait for that slab to be ready for the weight of bear the weight of an individual with a Chapin sprayer. So, the sooner it goes on, the better off you are because that surface is prone to very rapid moisture loss. And the sooner we get a final cure on there, the more of that moisture we retain, and the better it is for the durability and strength of that surface.
What are your thoughts on the solids content of curing compound? So we know it takes about 15% solids to meet ASTM C309. Again, what are your thoughts with regards to, 1L in mind and solids content of the curing compound?
Well, I have two thoughts about that. Um, First of all, I'm less concerned about solids than I am on moisture retention. So the moisture retention values are really, we assume that there's a direct correlation to solids, but that's not always the case. Um, so it can be solids of a material that doesn't do a good job of forming a film and preventing moisture loss, and so that solids number might give us a false sense of security. I would prefer to look um, at the curing efficiency of a particular product to determine, whether one is better than another. And that curing efficiency is a function of moisture retention.
I know we're starting to run out of time, but I think we still have a couple questions we tried to get to. Um, when we're placing stamped or decorative concrete, we're doing a lot of things to the concrete surface that are actually not very good for the concrete. So, with that in mind, what is happening with type 1L? Is that making placing decorative concrete even more difficult?
The short answer is yes. Um, and it's always been the case that the contractors in the decorative markets outpace the industry in terms of being able to come up with new and innovative decorative finishes that the industry hasn't doesn't takes a while to catch up to for testing and specification purposes. I would say that in the case of stamped as an example. I think that there is probably an increased, I think everybody would agree there's an increase in crusting that takes place and maybe some additional surface defects. But things like stamped concrete are outside of the traditional finishing and curing methods. And timing associated with a traditional broom finish concrete as an example. And certainly a finish such as exposed aggregate is completely different entirely, where we're using a surface retarder and we're going to come back and we're going to wash that surface away. So from a timing standpoint and from a surface strength and durability standpoint, we're kind of washing the problem away. Now we want to maintain moisture for the remainder of the slab, and we want to typically for exposed aggregate, we want it to enhance colors and deepen and enrich the appearance. But we might not have the same concerns in regards to crusting and map cracking and whatnot.
Um, just a reminder to everybody, this webinar you'll be able to access it on our website. All you have to do is look under the videos tab, and there are past webinars in that section. I think we have time for one last question, John.
Sure.
And that question is kind of a age-old question, or at least for us it is. And that is when you're applying silent cure on a green slab and it's creating membrane for curing, how is the silane able to work since the concrete pores are full of water?
Yeah, it's a good question. So I think I covered it in one of the slides. When silent cure is applied to a fresh slab, the acrylic portion sits on the surface. The silane is drawn to the alkalinity of the concrete, and the acrylic prevents it from evaporating. So as that moisture in the concrete, as the capillaries and pores are formed, because there's now some void structure that's being created, the silane is drawn down into that void structure. Let's also remember that the surface in particular for type 1L concrete is going to be drier than the surface of a type 1-2 because the moisture is not being replenished at the surface by bleed like it would normally be in with type 1-2.
Good to know. Thank you. That's all we have for everybody this morning. John, thank you very much for the information. It was very, very good. And again, we apologize for the mix-up in timing this morning, but we really appreciate you being with us this morning. I think it's a very important topic and look forward to presenting more information as we go. So thank you very much.